Getting the dreaded overvoltage fault can be frustrating, but if you understand what's going on, it's pretty easy to fix. First, understand that a variable frequency drive just takes an AC input voltage, rectifies it, runs that across a big capacitor to create a DC voltage, which is chopped or pulsed to send to a three-phase motor. By adjusting the timing of the pulses across the three phases, the drive can very accurately control the motor speed and direction. The overvoltage fault is referring to this guy, the DC bus voltage in the drive. If that voltage goes above what the internal components are rated for, well, bad things can happen to the drive. So let's play with this some so we can get a feel for what's going on. I have this single-phase 120-volt drive connected to this motor, which has a large cast iron sprocket and hub on it with a combined weight of about 12 pounds. That'll give us some inertia for the motor to work against. Inertia is just a measure of how much force is required to accelerate or decelerate an object. You have to push a lot harder to get something moving than you do to keep it moving, right? I also have the free WPS software up and running with a configuration and a resource already set up. My PC is connected to the drive using this USB COM module. Watch the WPS Quick Start video if you need a refresher on how to set all of that up. Let's do a factory reset on the drive so we're starting in a known configuration. These are the motor parameters, and as luck would have it, the defaults are fine for this demo, except the amperage for this motor is 3.2 amps. And I've already entered that. Now make sure your motor's numbers are in these parameters, don't use mine. Let's go to parameter 121 and set the frequency to 60 Hz, which tells the motor to run at full speed. The acceleration ramp is parameter 100. It looks like it defaults to 5 seconds. That's fine. Parameter 101 is a deceleration ramp. Looks like it defaults to 10 seconds. Let's speed that up a bit to a 5-second deceleration time. Now since the DC bus voltage is the key, let's go down here to Trend, right-click to create a new one. I'll call it Overvoltage Demo. Let's add a trace. Search on DC, and we see the DC link voltage is parameter 4. So I'll select that and hit OK twice to add it to our trend. I'm also going to increase the sample rate to every 50 milliseconds to give us a little more resolution. Well, click here to get the trend running, and press Run on the drive to start the motor spinning. As the motor ramps up to speed, the DC bus voltage sags a little. But now that we're at speed, it's holding steady. That makes sense. I'll press Stop, and we see the DC bus voltage rose quite a bit during deceleration. I'll stop the trend and click these to automatically resize the view. If I put the cursor down here, we see the DC bus voltage was hanging around this level. And if I put the cursor on the peak, we see the DC bus voltage spiked up to about 420 volts during deceleration. Why does the DC bus voltage go up during deceleration? Well, when the drive tries to slow the motor down, it has to overcome the inertia built up in the spinning sprocket. So the motor becomes a generator, which forces current back into the drive, which raises the DC bus voltage. Let's cut the deceleration time in half, which means the drive's going to have to work harder to stop the motor in even less time. Start the trend, hit Run. Let it ramp up to speed and settle out, and then hit Stop. Looks like the bus voltage got up to 440 volts. That's another 20 volts. Well, let's cut the deceleration time in half again. Start the trend, hit Run. Let it ramp up to speed, and hit Stop. Uh-oh, what happened? The drive gave us that dreaded overvoltage fault. Let's stop the trend, and we see the DC bus voltage got up to 475 volts as the drive tried to decelerate that massive pulley. And guess what? If we look in the programming manual, we see that the overvoltage trip point for this drive is 460 volts. Aha! So that's what the overvoltage fault is all about, the DC bus voltage getting too high. And it's usually caused by being too aggressive with your deceleration ramp. The cool thing is, you now know how to actually see how close you are to tripping the overvoltage fault, simply by looking at the DC voltage level on a trend while you run your system. How cool is that? Now there are some other things that can trip an overvoltage fault. First, since the drive is just rectifying the input AC voltage, the DC bus is proportional to that input voltage, right? So if the input voltage is too high, then the DC bus will be too high. So make sure you have the right AC voltage for your drive. For example, maybe you have 220 coming in, but actually have a 120 drive. Well, that would be bad, right? Second, if you have some other equipment that's messing with the line voltage, that could also cause an overvoltage fault. Put a voltmeter, or better yet an oscilloscope, on the input voltage and verify that it really is what you think it should be. Finally, if you're using dynamic braking and you set the braking threshold above the overvoltage fault level, the overvoltage fault will trip before the braking kicks in, which defeats the purpose of dynamic braking. What's dynamic braking? It watches the DC bus, and when it gets too high, it simply reroutes the excess current to an off-board resistor so the DC bus can't get too high. That's an awesome way to get fast deceleration times and protect the drive. We covered dynamic braking for the WEG CFW300 drive in a separate video. One final note. Do you have to use this WPS software to do this? Well, no. While it's really nice to be able to see the bus voltage change in real time on a graph, know that you can always see the last fault in parameter 50, 22 being an overvoltage fault, and you can see the bus voltage at the last fault in parameter 52. Again, 461 volts is over the 460 volt overvoltage trip level. And of course, you can always just go to parameter 4, the one we plotted on the trend, and watch the DC bus level while your system runs. For example, let's change the deceleration ramp to something bigger so it doesn't fault out on us. Let's scroll down to parameter 4 so we can watch the bus voltage in real time. Hit run, wait for it to ramp up, and then hit stop. Sure enough, you get a pretty good idea of what's going on. Click here to learn more about the WEG CFW300 variable frequency drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish new videos.